Welcome to a lesson with Dr. Powell. We're going to look at this recursive formula for sequence and prove that it's equal to 2 to the n minus 1 over 2. Now, there's more than one way to do this. You could actually do this very simply by thinking of a partial sum formula for a geometric series. But we're going to play around a little bit and see another way we can do that to kind of link some ideas together. And this same type of idea can be used in other cases when maybe the formula could not be obtained in such a simple way. But at least in this case, we have a target to aim for. And so let's go for it. So what we're going to do is we're going to first take this this definition and multiply both sides by x to the n. We're going to be thinking about polynomials. In fact, we're going to be thinking about series. Okay, and then let's just add up both sides and put them in series. When we're going to start adding at 0. So, and I'm going to write this as 3x to the n. And what advantage does this give us? Well, I'm going to call this f of x. This is very related to that in some sense. In fact, it's the same, except notice for a particular coefficient here, the power of x is 1 less than it should be. And also at the beginning of my sequence might be messed up just slightly. So I have to kind of think about that, except it shouldn't be, because remember that a sub 0 is equal to 0. So in some sense, since I'm starting at 0 here, let's just kind of see what's happening here. So my first power, if I'm starting at 0, let's just kind of list out the first terms here just to kind of see what's happening. Starting at 0, I have x to the, so I have x to the 0, which is 1 times, and what is this? This is put in the 0, that's just a1. So notice this is just starting at a1. And the next guy is, it's a2x, then you have plus a3x squared and so forth. Now, if you notice, and let's compare that to what f of x is. F of x is a0, which is just 0. So it's a1x plus a2x squared plus a3x cubed, so forth. Notice that if you just take this and you divide it all by x, look what you get. You get this. Awesome. So that means that this series right here is just f of x divided by x. This series right here is f of x, and then we have something over here. We're going to change everything kind of into polynomials a little bit. Okay, so what that enables us to do is write, so that enables us to say f of x over x is equal to f of x plus that series. Now, if you're familiar with geometric series, actually that's just 1 over 1 minus 3x. So think about this as being your common ratio r, and remember what we had, 3x to the n. This is just a geometric sum formula. So if we multiply everything by x, we're going to get f of x is equal to x f of x plus x over 1 minus 3x. And then if we subtract this over and factor out, see f of x times 1 minus x is equal to x over 1 minus 3x. Then we end up getting f of x is equal to x over 1 minus x times 1 minus 3x. Great. So look, we actually have f of x with all the coefficients that correspond to the sequence is equal to a nice polynomial over here. We're going to use that idea. let's take this and let's multiply it back over here. And so that would give us, in fact, if we multiply it out, we'd have 1 minus 4x plus 3x squared times f of x is equal to 0. Okay, now if we were to look at that and actually divide and distribute the f of x in that last one and divide everything by x squared, we actually end up having f of x over x squared minus 4 f of x over x. I'll let you go back in the video and see that in action if you want. Kind of think about what we're doing. So I just distributed the f of x through that and divided by x squared, and I get this. Now coming from here is like an a sub n plus 2, because I'm taking, because what I'm doing here, when I divide by x squared, how do you get the coefficient? How do you get the coefficient of x to the n? Well, the coefficient of x to the n is going to be 2 higher than what x to the n is, because I'm dividing by x squared. So actually the coefficient of this is going to be an plus 2. So just look at coefficients of x to the n everywhere. The coefficient over here is going to be, I'm going to have minus 4a, so I get minus 4 times a n plus 1, and this is 3 times a n, and that's equal to 0. Great. Now I have a recursion that I can use right here, that I can use a matrix with. And in the next video, we'll pick up this problem and go on from there.